This is the presentation for CECS 361, our final project. It is a kitchen timer. You will hear the voices of my partners Joshua, Edwin, and I presenting this, and at the end there will be an onboard demonstration.
The device we will be using for our programmable logic alarm clock or kitchen timer is a Nexus A7.
The goal of our final project was to make a kitchen timer that can also be used as an alarm clock that has a programmable time setting that is operated with buttons and switches. These are commonly used in kitchen appliances like microwave, an oven, anything that has a timer that you enter time and it counts down and it'll let you know that it is done.
The inputs into the board we have utilized are the onboard buttons and switches, and the outputs will be the 7-segment display and the RGB light.
The user interface is the onboard buttons on the Nexus A7 because they're already incorporated onto the board and they're simple to use.
However, there's one issue that happens when you're using these simple buttons on the board, that when you press it, the electrical signal fluctuates and makes it hard to detect when there's a solid press or not. And a sort of logic bounce occurs, meaning that when you press it, it could register multiple presses.
The way to fix this issue is to debounce the button and filter the inputs so that you only get one button press for every actual button press to avoid any unwanted inputs.
The inputs we use for the kitchen timer are the onboard switches and the onboard buttons as mentioned previously, and they can be used through the use of debouncing to feed accurate inputs.
The buttons are used to increase the amount of time on the timer, which can be incremented in 1 second, 10 seconds, 1 minute, or 10 minutes. And then the switches are used to reset the whole timer, or they're to start the timer.
There are 2 input switches, one to handle the reset and one to handle the run, and that allows you to pause the timer at any point and add more time, or just reset it while it's running.
As the computer's clock is way faster than anything a human can perceive, the signal to update the number on each 7-segment display must be slowed down so it stays on each number while it is being constantly updated.
When the start-stop switch is low, it waits for buttons to be pressed and updates the time accordingly for each button that is pressed. Then, while the reset is off and the start-stop switch is turned on, the timer starts counting down all the way till it reaches 0.
And once it reaches 0, it sends a done signal to the timer module to stop counting and a done signal to the RGB LEDs to start flashing to show that the timer is done. And the LEDs keep flashing until the reset switch is turned on.
The 7-segment display consists of anodes and cathodes. The anode controls which segments are on, while the cathode controls which digit is displayed on the individual segment. They share a common anode and a common cathode, meaning when you change the cathode, it would affect all other anode segments that are on.
In our project, we're using 4 of these segments from the board. And since we can't just pass in one number like 24 minutes and 53 seconds to change all the segments at once, we have to pass in one digit at a time through time multiplexing. We do this by dividing the clock into 4, since we are using 4 of these segments. Even though the clock is divided, it will still be fast enough to trick the human eye to seeing 4 digits on at the same time.
The refresh counter counts up to the amount of anodes and digits that will be displayed. It will also choose which anode and digit to display by using an anode and a BCD control. Once the refresh counter has chosen the digit to display on its corresponding anode, the digit goes to a decoder. The decoder will then translate the digit into a number the cathode can display on the segments. And now we have the onboard demonstration for it by Joshua.
This is the onboard demonstration for the kitchen timer. And in this project, there is the timer that is shown with the 7-segment displays. We are using buttons to add the time. there's a start-stop switch, and then there's a reset switch to reset all the numbers to 0. The start-stop switch starts the timer, and when that's in the on position, and when it's in the off position, it'll pause the timer and it'll let you add time with the buttons. So right now we can add time. I'll show you that each one works. So added 1 to each. This adds 1 to the minutes and tens place. This adds 1 to the minutes and the ones place. This adds 1 to the seconds in the ones place. This adds 1 to the seconds in the tens place. And we can reset it just like that. And then I'll put 10 seconds. When the timer runs out, the RGB will start flashing, letting you know that the timer is up. Okay. And then you can see it start when I press this. Or flip that to on, the start stop. And right now we cannot add time, as you can see. Now it's ticking down all the way to 0. And the RGB flashes on and off. And to stop that, we just flip the start stop switch to off. And I'll show you that each one works. So I'll start it, and then it starts ticking down. Can't add anything. And then we can pause it just like that by turning the start stop switch off. And then we can add time as well by just when it's off, just add time, and it just starts again. And that is the onboard for the kitchen timer.